Hi. Uh, Let me briefly show what I want to implement. So I have this game, Sea Trader. Well, basically, it's not a game yet. It's a pile of shit. But for now, I can move this this, let's say, boat or whatnot manually. So I basically press control buttons and I move. Also, I implemented a star pathfinder. For instance, I can click right button and it provides me a path, shortest path from my current position to the selected one, like so. And actually it works really fast. I optimized this shit a lot, but now I want to implement some kind of path following. So if I have a path, I want the boat to follow this path automatically. And I kind of implemented this, as you can see, if I press button, it starts moving, but it moves, it's not okay, as you can see. And the idea is that I want to move it smoothly. I want it kind of predict the turns, and I want the boat starts turning beforehand. I explaining it badly. Let me just draw this. Let me open Excali draw. What is this? Give me a second. Oh, what is this? So basically, let's say that I have an object. And I have some kind of predefined path. It consists of like points, checkpoints, let's say. And when this boat is moving towards the, well, basically I want this boat to follow this path. And when the boat is moving, for instance, let's say it moves like a straight line, but then it comes the moment that when boat needs to turn, in this case turn right, like so. But since I've implemented the basic dynamic physics, the boat it can overshoot the right position when it should turn, actually. And when the boat is here, it will overshoot this point, and only after that it will turn. And in reality, we will have the situation when the boat, I will just draw the trajectory of the boat. It will overshoot this turn, then it will return to the path, it will overshoot it again, then it turn back, overshoot, and so on. And this kind of wiggling, how should I say it? Yeah, wiggling behavior, it's not okay. It just doesn't look right. What I want to achieve maybe sort of this kind of behavior. Yeah. So it's a little bit overshooting, but then boat returns to the right place, to the right direction. And if I have, for instance, simple, not simple physics, but if I don't implement physics, if I implement only the immediate steps, for instance, I can manipulate this boat just changing the direct position. I won't have this kind of problem at all, because I can change the boat position directly. I can put it here, then here on the next frame, I can put it here, and so on. But in my situation, I have simple physics. It means that the boat is influenced by external forces. And in my case, external force is just a boat thrust. I always forgot spelling thrust, yeah? And this is kind of external force which drives boat to move forward. And this physical proxy, I should say, this physical force, it just doesn't allow me to influence boat position directly. And it means that I need to introduce some kind of, I don't know, automatic, they call it control theory, basically. It's when you have some kind of object and you have some kind of target. It's not necessarily the positional target. For example, you have a toilet, and the toilet has a level of water in the tank, and you want to fill up this water to the specific position such that the water doesn't overflow this tank. And it's basically also the control theory problem, because you want to understand how much you need to add water, and the speed of water flow the water flow itself, it basically can't stop immediately. Like in our case, the movement cannot stop immediately. It has some kind of inertia. And we want to predict that we need to stop the water flow right now, and after, for example, a few seconds, the water flow will reach the target point. So it's basically also control theory. Yeah, and I wanted to implement this stuff. And there are a lot of ways to handle this behavior, and maybe for games, for simple 2D top-down stuff, or maybe side scrollers, or maybe, I don't know, you can handle this kind of problem maybe by hard coding some variables and whatnot. You can predict the next point, you can start turning beforehand, and so on. But the general solution would be something like they call it PID Controller. P stands for proportional, I stands for integral, and D stands for derivative, I suppose. Well, basically, it's more or less math-heavy stuff. We can Google it, PID Controller. No, sorry, not PID. Yeah, it looks ugly. For me, it looks ugly. It's math-heavy. It's for scientists. It's not for programmers. But I want to implement, because from my university years, I remember that this stuff works all right for this kind of problems, and I want to implement this. And for this, I can just close this. Yeah, and for this I built basic template to play with this sheet. Tutorials, physics 2D. For now, it looks like this. I have this boat, and the boat it can move. It basically moves with huge inertia, as you can see. And this world has simple physics simulation. For instance, I have inertia, I have mass of the boat, I have moment of inertia. Moment of inertia is basically like a mass, but for for rotational movement. As you can see, I can rotate, but if I stop the rotation, boat continues to rotate a little bit for few moments. And the same is for movement. If I stop moving, the boat continues moving for several seconds. Yeah, and I want to implement this kind of automatic not path finding. I don't want to implement not path finding, path following. I want to implement path following here. But for now, I have only manual controls. And I implemented these manual controls on in my previous video, so you can check it. Basically, it's just basic. It's just simple raylib setup. I have simple draw stuff. I draw boat. I draw coins. I update inputs. In update inputs, I just collect pressed keys. I can rotate. I can move further. I can spawn coins by pressing right mouse button. When I am updating the boat, I compute this external force, and in my case external force is only the thrust force. So when I let me open in another tab, tutorials, physics. So when I press space button, I basically increase thrust of the boat, and it moves further. And given the thrust, I can compute force. Given the force, I can compute acceleration. Given the acceleration, I can compute velocity change. So like velocity step for this specific frame. I can compute the actual velocity by adding my current velocity and this velocity step, and also I apply some kind of friction force, and I obtain new linear velocity for the boat. Then given this new linear velocity, I can compute position step for the boat and just assign these new values to the boat. And actually the same logic for rotational stuff, but in rotational let's say math, we don't have 2D vectors. Instead we have just single floats, because it just doesn't matter for now. You can check this code by yourself. Basically it looks the same as for linear movement. I update the rotation, I update the angular velocity, and I just clamp the rotation angle. Update coins. Here I just check that if coin is close enough to the boat, I assume that the count is collected, and I just increase the counter of the collected coins. Drawing function, draw coins, and simple UI. Yeah. And since I don't know how to, actually I don't know at all how to implement this PID controller, I just remember that this stuff may solve my problem. And so probably I would like to use, well, I would like to use Googling for this, but I don't want to use browser when I'm recording the video, because my computer is going crazy when I'm recording the video and when I opening the browser. So I would like to use maybe ChatGPT. I'm using basically not ChatGPT, I'm using another LLM, but it doesn't matter. Just to guide me towards the final solution. And I think it will be a fun experiment to use LLM for C/raylib programming. Yeah, let's begin. Well, let me just grab this stuff, go to the chat companion and just ask the direct question. I have this simple 2D physics, and now I want to implement path following. and as you can see, I have a simple dynamic movement, e.g. the boat doesn't change the position directly, but instead it is influenced by what? By linear force, thrust, and by rotational force, angular thrust. I want to implement this kind of automatic path following using PID controller approach, but I remember nothing about PID controllers and control theory in general. Provide me a GUI guideline. Okay, let's just start and check the output. Certainly, classic beginning. Define the path, implement PID controller. I like this. Just draw the all. Define the path, implement PID controller, calculate the error for steering, PID control steering, thrust. Yeah. By the way, I forgot the word. They call it steering, not the linear thrust. I will call it thrust because, as you can see, I have angular thrust, but the correct term is steering. Steering is basically angular thrust, but I will say that I have just angular thrust. I don't want to rename stuff. PID controller. Define the path. Okay, it's understandable. Implement PID controller. It's okay. Calculate error for steering. Okay. Yeah, I need an example. PID controller. For PID controller, I have 3 coefficients for proportional movement, for integral movement, and for not movement, but how should I say it? For component. I have proportional component, integral component, and directional derivative component. I have accumulated integral and error. All right. I have a path, points, current point, and also LLM defines PID for thrust and for steering. So apparently I need 2 separate PID controllers for linear movement and for steering movement. You know what? Let me maybe rename all the stuff. Before we begin, can you please rename angular thrust to what? To steering in my original code. Rewrite all my code. Don't introduce any PID logic yet. Just rewrite the code. Yeah, looks okay. It looks okay. Let me compile this. Okay, it works. Steering and yeah, and as you can see now, I operate in terms of steering, not this weird angular thrust term. Right. Okay, now break the PID stuff implementation on small step and provide them to me with explanations. What? Certainly. So let's start by defining structure for PID controller. Okay, let's define it. Where was I? Where was I? Pass, PID calculate, PID controller. Yeah. Okay, let's say that I have a PID controller. Explanation. Structure holds necessary components for PID controller. The gains, 3 gains for proportional, integral, and differential determine the influence of each term. The integral accumulates error over time, and previous error is used to calculate the rate of change. If you don't understand this, I also don't understand this. Yeah. We will see on practice how it will work, but for now just let's continue. Initialize PID controllers. It's tutorial for programmers, not for mathematicians and whatnot. Initialize PID controllers. Okay, I can do this. Explanation. We create 2 PID controllers, one for steering, one for thrust. The values 1, 0, 1, 0, 1. Initial guesses. Okay, you'll need to tune. Yeah, and well, it will be another topic how we tune these parameters. For now, we will just tune them manually. We just hardcode them. Implement PID calculation function. Add this function. Okay. PID calculate. You know what? It's not my style. I don't like sorry, it's just my thing. I don't like the capitalized comments. I don't like capitalized variables naming. And also I prefer explicitly name the struct PID controller. It's okay, alright. Yeah, and calculate, probably it's update PID, yes, it's update. What is happening here? Explanation. Function performs PID. It takes the current error and time step dt as inputs, updates the integral and calculates the derivative, then computes the weighted sum of the blah blah blah. Path structure. Well, okay, maybe I want to get rid of these coins. Well, I need to implement this path construction. How can I do it? For now I have just static array of coins, and when I spawn the coin I just add new coin to this array, to the empty slot in this array, and I define the emptiness of a slot with this flag attached to the coin. So it's, if coin is spawned, it means the slot is not empty and I cannot spawn new coin in this particular place in the static array. But if the coin is not spawned, basically this branch, I can spawn it, I can set the position, I can set the size, blah blah blah, and I can break. Break means that I found the empty space in my array, I spawn the coin, and that's it. But maybe I don't want to keep this coins. Let me name this like path maxim coins. Add coin to path position. Now I will iterate over all the coins. I will find the empty coin. Maybe I should create type diff struct pass coins max and coins. How do they call it? Current. I don't like this. I like explicit. Sorry, I just thinking out loud, and probably it doesn't make a lot of sense. But let's say that I have integer value next coin IDX. Do I need number of coins? No, I don't. I will treat this array like C string. It's basically null terminated array, but in my case the null termination means that is spawned is set to false. It basically, I just don't want to track separate number of coins in this path. I don't need this stuff. Add coin to path position. I iterate over all the coins in my array. In my path, I take path coins. Yeah. Path. I take this coin. I check if the coin is spawned. I just continue, and if coin is not spawned, I just spawn the coin, like so. Yeah, but now I can't collect all the coins. Actually, I cannot collect any coin on this path. I can't collect only the next coin. So when I'm updating when I am updating the coins, I take this pass coins, I take the coin, I check if the coin is not spawned, I just break, because it means that we reached the null termination of our coins array. But if the coin is spawned, I need the coin to be spawned and the coin to be the next point in my target, in next target point in my pass. So basically I check that if coin you know what, I don't need this loop, because I already have pass next coin IDX. I take this coin, I just take this coin, I check the distance to the boat, and also I need to check that if coin is not spawned, but for some reason the IDX is set, let me say that if pass next coin IDX is equal to -1, it means that our pass is finished. We collected all the coins, and I can just return here. But if this next IDX is not -1, I can take this coin, I can check that if the coin is not spawned, and if the coin is not spawned, something strange is happening here, because I have the next coin IDX, but for some reason coin is not spawned, and I can raise the error here. How can I raise the, well, I can basically exit, can I? Sorry, I'm not C developer. I don't know how to raise the error. I don't know why I don't have the exit function. Exit CS. For some reason, I don't know why. I hate this. How can we raise in let me remember this. Yeah, sometime I have brain farts in C because I don't know this language. Not at all, but can you please put error raising in this if statement? No. Just exit C code immediately and log an error. Exit. Why don't I have this stuff? Yeah, I have this one. For some reason, just my auto-completion doesn't work. It's okay. Yeah. Yes. Error. Pass contains not spawned coin. It's a bug. Okay. Yeah, now I can return back to this PID stuff. Update coins. I take the coin, I check the distance, I check the distance. And then I just say that coin is not spawned, and I increment the number of coins. Okay. This should be it. Maybe it's not update coins, but it's update pass, maybe pass. Draw coins. Yeah, I need to take pass coins I. Add the coin to pass. Like so, and update pass. Yeah. Spawn coin. Add coin to pass. And now I just can't collect this one because I first need to collect this. Whoa. Yeah. Okay, why so? Yeah, because next coin ID X, I need to set up next coin ID X. How can I do this? Pass. Add coin to pass. Create pass. Next coin ID X is equal to -1. And when I update pass, when I collect the coin, I want to update next coin ID X plus equal plus equal 1. I begin with 0. And now I somehow need to set up the termination condition for the pass. For the pass. How can I do this? Well, basically, it's not an error. When I find the coin which is not spawned, I basically reach the termination, the final coin in my array. So I basically say that if coin is not spawned, I just say that pass next coin ID X is equal to -1. Well, I can fprintf. Well, actually, the raylib has trace log info. All coins are collected. I don't know if it's grammatically correct, but probably it is. All coins are what? Are collected. Yeah, it's correct. Yeah, probably this is it. This will not be collected, but this one will be. Now next coin, and now the final one, and the trace log. Yeah, all coins are collected. I can add new coins. I can collect Y. Yeah, okay, it's all right. When I collected all the coins, what should I do? Spawned. Yeah. If pass next coin IDX is basically -1, basically it means that we haven't initialized the trajectory yet. I can initialize it. Pass next coin IDX is equal to 0. Let me collect this one, place this one. This won't be collected. This will be collected. Yeah, all coins are collected. It's not correct because not all coins are collected. Something is wrong. Yes, because I need to iterate. Let me think. Yeah, I'm iterating over all the coins when I'm adding the new one. But it might be that some coins are already collected, they are not spawned, the flag is not true. But I need to iterate to the last spawned coin. Integer last spawned coin IDX is equal to -1 at the beginning. I iterate over all the coins, and if this is spawned, I say that last spawned coin is equal to I. I don't need this one. And now if if last spawned coin IDX is equal to -1, it basically means that no coins has been spawned. Like so. Pass coins coin IDX is spawned true. Well, coin is equal to this. Coin Yes, okay. It's a little bit convoluted, but it's okay. So I can collect this one. Okay, I can spawn the new one. I can collect this one. I cannot collect this one yet. I can collect this one. Now I cannot collect this one. I can collect this one. Yeah. Now I can collect this one and trace lock appears. Yeah. So now it's all correct. I can set up path. I can follow path. Yeah. Now let me modify draw coins. Let me say draw path. Let's say that color is equal to path next coin IDX is equal to I, then how can yeah, like so, is equal to I say that the color is, for instance, gold. Otherwise the color is let's say gray. I just want to highlight the current target, because now I kinda don't understand which coin I can collect and which coin I cannot collect. Color. Yeah. Nice. Let me commit this one. What did I do? Yeah, pass. Let me remove this for now. Controller. And I return PID stuff back. All right. Okay. Now what? $6,000 tokens. I need to start over. Unfortunately, because 6,000 tokens is kind of expensive. But well, okay. Let me just continue to follow this guide from the LLM, from the stupid LLM. Calculate update PID. Okay, explanation. Yeah, we define the path. Blah blah blah. Update path following. Yes. I need this kind of function. Update. Well, maybe yeah. It's literally not update PID. Yeah, it's I agree with LLM here. It's PID. It's you know what? It's apply PID. It's apply PID. Not calculate, not update. It's apply. We applying this stuff. And now update input, update bold, update pass, void, update pass following void. Delta time. Okay, it's understandable. Calculate steering vector. What the fuck are you doing here? Explanation. Well, not too much explanation. You know what? I have an idea. I have an idea. I will just put empty function here with delta time. Update pass following. Yeah. And now I want to grab my initial explanation. Like so. And repeat the procedure. Code companion chat. Blah blah blah. And finish my my implementation step. Let's go. Certainly. Proportional derivative. Yeah. The steering thrust. Blah blah blah. Yeah. Update. Going to follow. Yeah. Yes, now I like this. Let me copy this function, update pass following. Let me Well, why do you need this condition? Probably you don't need. This one is enough, I hope. If it's not enough, it's a bug. It should be enough. Target position. Agree. Vector from boat position to target position. Agree. Distance to target, yeah. Desired angle. Yeah, okay. It's just an angle between what? I always forget a tangent is angle between what and what. Target Y to target X. Yeah. It's angle between the X coordinate and the to target vector. And for some reason we flip it. Probably because I don't know why. Calculate angle error. Desired angle boat rotation. Agree. Angle error. Normalizing of angle. Okay. Apply steering. What the apply steering, apply PID, we take steering PID, angle error, blah blah blah. Agree steering, clamp, max steering, max steering. Okay. Thrust output, clamp, linear thrust. Slow down distance. Reduce thrust when approaching the target. Maybe 10 is too much. Maybe let's say. So basically, the boat size, the width of the boat is what? Is 2. Yeah. Yeah, it's 2. Yeah, maybe 10 is okay. Maybe 10 is okay. Distance to target, linear thrust. Yeah, and we just proportionally decrease this. Not proportionally, but what is this? Distance to target divided by slow down distance. Yes, just proportionally to the distance to target, to the ratio between distance to target and slow down distance. Maybe I don't know. For now, I don't need this. Okay, understandable. Clamp. We don't need clamp. Update pass following, and now we can just apply this update function. Update pass following. Update pass following. Let's try. I don't want to add coins at the beginning, so the boat will stand still when I run the application. Make. Oh. For some reason, what is happening? No, nothing happens. Nothing good happens. Fuck. I have a meeting on my job. I need to interrupt, sorry. Так. So, let me continue. Where did I stop? So we have this basic. Well, first of all, as you can see, steering is constantly. I constantly collect coins. First of all. What the fuck? Okay, update. Let me name it not update pass, but probably update coins is better. Update coins. Update. Update coins. And now next coin IDX. When I'm initializing next coin IDX, basically -1. Yeah. Angular speed. why steering is 0? Steering, boat steering, clamp. Yeah, because this stuff is basically setting it to be 0. Probably no. What the? Boat steering. Yeah, next coin. Yeah, I understand. You know what? Let me, when I am updating the path following, I also, well, currently there are two ways to control the boat: by automatic path following with PID controller, and by input. Let me say that you know what? Maybe for now I just won't touch the control buttons. Let me As you can see, I placed a coin, and the linear thrust started to increase, but it's too slow. And also, for some reason, steering doesn't increase. Did I comment steering update path following? No, I didn't comment this. Well, I have no idea what's happening, but something is not correct. Let me maybe increase these coefficients. When we applying PID, we obtain the output, and the output depends on the error, it depends on the integral, and integral is just integrated error, and it depends on the derivative. And derivative is basically difference between current error and previous error by dt. It's derivative. And I want to increase output. Let me say, for instance, steering maybe 111. I know it doesn't move. It doesn't move because I need to update. Give me a second. I need to update path following maybe before I update the boat. Update boat, maybe I should do it like so. Or maybe even like this. Nothing happens. Yeah, and now it rotates, as you can see. It rotates. Let me increase coefficients one more time. 10, 10, 10. And as I can said, we kind of need to tune these coefficients later, because in the naive hard coding it usually doesn't work. linear speed. It overshoots. It overshoots. Okay. Well, actually, it works fine. Actually, it looks good. I like it. It doesn't overshoot too much. Yeah, it's kind of yeah, it's kind of difficult. Maybe where I need to uncomment this part of the code. Yeah. Now I understand why we need this. We basically want to slow down when we are near the target point, near the target coin. Maybe even 20. Maybe even 20. Also, maybe I want to maybe decrease this. I don't know. I just guessing right now. I just guessing. Really, I just guessing. I want to achieve more or less plausible result, and after that I will implement I don't know, some kind of procedure to fit, to auto-tune these parameters. But for now I just want to be it visually plausible at least. Okay. Yeah. Maybe I need to decrease thrust and steering. Maybe steering, maybe thrust, maybe steering. So. Come on, come on. Yeah, it's fine, it's okay, it's all right. Well, at least it's something. Okay, for now I will stop for now, and next time I will implement sort of, I don't know, I just need to tune these parameters, because maybe I will start with implementing sliders to modify these parameters like live in the game when the game is running. This is first thing I want to implement next time. Also, I want to understand how each of these parameters basically affects the behavior of the boat. Yeah, and third, I want to implement auto-tuning of these parameters. But now it's already looks good. I already like it. Okay. So let me commit this. Yeah. Yeah, and I need to create repository. So yeah, that's it for now. Thanks.